we're going to just take 2-3-step algebra problems, solve them. But what we're going to come up with are reasons and rationale behind the steps that we do. Because as you get further into first semester geometry, the more that we're going to see these nasty things called proofs, where we have to use definitions, theorems, postulates, whatever, to show how certain things work and how you can come up with the next valid statement. So the idea behind what you're doing the past few days with detachment, syllogism, coming up with valid conclusions, is kind of the preface to what you can say and when. All right. So we always start this stuff by looking at algebra problems that you guys have all done. You guys all passed algebra, which means you have to remember. You should, I shouldn't say have. You air quote should remember how to set up and solve some of these things. Okay. For example, if I start with the equation 2x plus 3 equals 7, what's the very first thing you're going to do to solve it? You're going to subtract 3. Now, you're going to subtract 3 from just one side? And why do you have to subtract it on both sides? It keeps it equal. Correct. It keeps it equal. Okay. So you subtract 3 from both sides. And then what do? You rewrite it. When you're rewriting all this stuff, what in essence are you doing? You're not solving. You're making it smaller. You are simplifying. Very good. You're simplifying what you're replacing. You're simplifying this part. Solving is when you're done. Okay. What do you do next? You know how to do it. Are you dividing just on one side, or are you doing it on both sides of the equal? Again, you're dividing on both sides of the equal. And then what's your answer? 2. Okay. So what you're doing is that you are actually listing out, you're telling me via all these algebraic steps how to come to the conclusion of the answer of x equals 2. Well, it's kind of the same premise as what we start to get, and don't write this out yet, is that eventually we're going to get something like this where you're going to be given that x is a midpoint of AC. Prove AX is congruent to XC. Okay. Well, you have to understand what you start with, what information that is given to you, what reasons and definitions can you use to come up with generating extra steps to come with the conclusion of calculators are heavy. No, I mean, AX is congruent to XC. Okay. What you guys did is that you used properties to show that each of these work. Now, you may or may not have seen something like that. Any of your friends have had geometry in the past, you've seen this. This is called a 2-column proof. Why is it 2 columns? Because there's 2 columns. Yes, sir? What's that? Yeah, I'm going to explain what it all means. Okay. Now, when you have a 2-column proof, there's, well, obviously 2 columns. One column means something, one column means another. Well, the column on the left is what you're doing. We call those statements. Why you're doing them is called your reasons. Okay? Reasons are always going to be properties, definitions, given statements, theorems, postulates. There's a whole bunch of little things like that. Statements are always going to be what you're doing from them. What can you say next? Well, we started with something with an equation. We knew the process behind that was to, well, work backwards from PEMDAS, subtract from both sides, rewrite, simplify, divide both sides, and you were solved because you were done. There was no other mathing to do. Well, in geometry, these reasons start out as algebraic properties. And we try to work as much with the algebra with you guys first because you just got done with algebra. So it should be pseudo-fresh in your brain. And that way you're able to get through the idea of putting this together without the skipping of steps, without the trying to go too fast through. Because two-column proofs take a little bit of time to get used to. The algebra is the easy part. It's the rationale behind it what takes a minute to learn. Okay? So let me show you guys what we're going to use to start with what's called our reason bank. And then we will put your feet down, please. Put your feet down. No. So, for today, what we're looking at, guys, is this reason bank is going to be kind of like your best friend over the course of the next couple of chapters. This is something that, as geometry teachers, we allow you guys to use on quizzes and tests. And we're also going to add stuff to this. We're going to add abbreviations. We're going to add, yes, sir. Yes, now you have to not be able to use this on a quiz.
Well, yeah, I know that, but like.
Here's the thing.
Okay. I got it.
You're safe. So nice. Remember, don't lose this. A lot of this stuff that's on here, we're going to create another document off of this, and then that one is going to be what I'm going to call a progression sheet. It looks very similar, but it's going to tell you, it's going to be a bunch of squares. That'll tell you kind of like if given a midpoint. If you're given a midpoint, what does a midpoint do? What does it create? 2 seconds. What about those 2 seconds? Okay. So if you're given a midpoint, you would state some segment is congruent to some segment. Your reason behind that would be then definition of a midpoint. Now, I know that this probably looks very foreign to you right now. But come Thursday, when we talk about segments and we talk about angles, which we'll do some proofs out of these things, this idea of seeing that if you're given x is the midpoint of AC, well, if x is the midpoint of AC, what 2 congruent segments would have to be formed? X is the midpoint of AC. What would they have to be? And XC. And the reason behind that would be the definition of midpoint. What I'm getting at here is that these properties, for today, we're only going to be using like 4 of them. These properties are quite literally what it says up here, your reason bank. Okay? For example, when I give you something to do, that means it was given to you. All right? So the first thing you wrote down was this algebraic equation, 2x plus 3 equals 7. Well, the reason that you wrote it down because it was given. Okay? Yes, sir. I would say 99.9% of the time, your very first thing you write down will always be your given. Okay? For the reason side. The next thing, notice we subtracted the same thing from both sides of an equal sign. Well, that's actually a property. Subtraction property of equality states that if A equals B, then A minus C equals B minus C, because you're keeping it equal to both sides. So there's going to be some abbreviations I'm going to let you guys use. So on your sheet here, I want you guys to put down some of the abbreviations that I use.